लेकिन स्टार्ट ऑप्शन रखे बंद करवाएंगे तो उसको बोलो मैं स्क्रीन पे कर दूँ। अब वो आधे घंटे लेने चलूँगा तो
Devi, you can start your presentation now. There's actually a half an hour delay just now.
Okay. I have a demo in the talk. Can I share my own screen?
so in camera yeah
Oh, what's it called?
hello
Hello.
yeah so actually there's a 30-minute delay so you can start now.
Yeah, I have a demo in my talk. So can I share my own screen?
So you have demo as well.
Yeah.
Okay, yeah, sure. So let's see. Hello. Hello. So yeah, so Divi, can you tell which one is yours to save?
This one, the one it's displayed right now.
Okay, yeah. So this is not required then. So you will share your PPT as well.
Yeah,
Okay. It's quite.
Divi, the the screen.
So I guess now you are shared. So actually we will start. So actually we are having a 30 minutes delay here. So now we can start
okay,
our
yeah,
session. So Divi, the software engineer at Dino. Yeah. So Divi, you can start now.
sure, yeah, thanks. Uh, yeah, hello, I'm Divya, and my talk for today is about JavaScript runtimes and how they relate to operating systems. Um, so if you have ever used something like Node.js or Dino, or maybe you've worked on a React project, then this talk might give you some deeper insights into how all of that works internally, and hopefully also kind of just let you appreciate the optimizations that go into these open source softwares. Um, so a little bit about me. I'm a software engineer at Dino, and for the past 3 years, I've been working on the open source CLI and currently part of the core team working on Node.js compatibility. And in the free time, I like runtimes, compilers, and cryptography. Um, so what's Dino? Um, Dino is an open source JavaScript runtime that's built on top of Chrome's V8. This is used by Google Chrome and Microsoft Edge in their browsers. And also on the server side, it's used by Node.js and Dino. Um, the reason Dino is different from Node.js is because it's slightly more modern. It supports web standard APIs, has like built-in TypeScript support, permission systems, and also is compatible with old Node.js legacy code and npm. Um, so let's dive deeper into how JavaScript applications run on the server side. So JavaScript language itself is entirely single-threaded. So any user code that runs JavaScript is only happening on a single thread. And let's say you want to read a file. So you would actually have to read the file in a way that does not block the main thread. Otherwise, all the user code JavaScript that's running will be blocked until the file is read. And for high performance systems and like for web servers, this is kind of not what you want. You want everything to be unblocked and all the IO to be offloaded to another thread or happen concurrently. So the way this works in JavaScript runtimes is that there's an event loop that's built using kernel APIs like epoll and IOCP on Windows. Um, and so, for example, when you read a file, and if the file is not ready, the syscall for open will return um, again, which means like try again, because this is currently blocked. So the way event loops in single-threaded JavaScript runtimes work is that when you read a file, it will register that file with the kernel using epoll register, and then when the file is ready, the kernel will notify us or the program in this case using epoll wait um, when the file is ready to be read. And so that way you can keep running existing like user code on the main thread and wait for IO notifications using epoll. Um, and in JavaScript runtimes, all the IO operations are offloaded onto this event loop. And then when the operation completes, it's then pushed back into the JS side using promises or callbacks. Um, Here's an example of an HTTP server entirely in JavaScript, and this is just one line. Um, there's a lot that happens inside of this machinery that's like very hidden. Um, this runs entirely single-threaded. It can handle up to 130,000 K RPS on local machines with a P99 latency of just 1 ms, and it's entirely in JavaScript. So you can imagine all of this is run using a concurrent event loop instead of a parallel, like multi-threaded one. And the thing is, you can also run this multi-threaded by just stacking many of these single-threaded event loops onto multiple threads. Let's look a bit at how scheduling works in these event loops. So here I have an example where there are two files. Sorry, just one file. So we open this file called index.html, and we currently do not read from it. So this will just open and give us a file descriptor here. Then we call fetch on like a website, and what it will do is connect to this website and then give us the response back. And then in the next line, we read the response body and then pipe it to the file. So it will write all of the stuff that's in this website to index.html. And so you can imagine, you can break this into two parts. So the first part is these two statements, which open the file and then connect to the web server. And then the third statement is where we pipe the request body to the file. Let's look at how these two statements are scheduled on the event loop. So if you see here, there's an await point for both of these. This means that this will run the open syscall on another thread, and then it will not run beyond this until the open syscall completes. Await means that if there is a previous running IO operation, it will not be blocked. So this is a non-blocking syscall in a way for JavaScript. And so in here, you can see we call open, Dino internally then calls open at the Linux syscall, and then Linux returns fileFT, and then Dino returns the file handle to JavaScript. The same way for fetch, it fetches, it creates a socket, connects to this server, then registers that socket as readable so that the event loop can then do its job and then notify us when the socket is ready to be read from. And then we get the response back, and then we have the connection handle back in JavaScript. So this was all sequential. This means these two operations happen one by one instead of concurrently. The pipe to statement that we have in the last line is actually concurrent because it first pulls from the response body, and then it waits until the socket is readable. So Dino sends the request, sends the syscall to Linux, and then it will wait for the socket to be readable. Then the socket is readable, and then we will read from the socket file descriptor, and then that will return bytes. And then Dino will return all those bytes back to JavaScript. And when that happens, we write to the file that we opened, the index.html file, all those chunk that were read from the socket. And then this resolves the first promise, so the first write. This can happen multiple times because you might imagine reading only like half of the file the first time, the second half is not ready yet, or the server hasn't sent it yet. So it will stream it the next time. So this happens continuously, and this automatically applies back pressure, so the event loop is not overloaded. It can also work in a way where you read the first two times. So these things happen the first two times, and then the third event loop tick is when we write all of that. So that's why this is concurrent. And this is entirely non-blocking. So any other code, for example, if you have timers running or a set timeout running somewhere, that would still run, that would not be blocked. Another property of Dino is that it supports permissions. So you can actually limit your script, like what it can do, what syscalls it can perform. So, for example, in our web server, we depend on the network interface. And so we can completely disable that by default by just not supplying allownet. If you supply allownet, it would work. And internally, this just does check before calling the actual Linux syscall for creating a socket. And if there's no allownet, it would just stop. So this is like a virtual permission system on top of the JavaScript runtime. Now you might be wondering how do you actually close the socket when you're done reading or writing? Or yeah, what about like files and other resources? How do you like get rid of them once you're done reading? So JavaScript objects in general are garbage collected. That means you don't really need to do manual memory management. So you don't have to call free on a file descriptor or like free on like a allocation of some sort. So how do we clean this up then? How do we know when to clean up files and sockets in a JavaScript runtime? That's where resources come in. So resources are like file descriptors. So when you open a file, you actually get an integer back, and this integer represents the type of resource that you're holding in JavaScript. And that maps to something in Rust or like in the native side. So you can see by default there are like three resources for the standard IO, standard in, standard out, and standard error. And then you can close standard in by just doing dino.close. So this is like entirely manual memory management here. So internally, this would close the file descriptor for standard in, which is 0. There's also garbage collectible resources, which means this takes advantage of JavaScript's GC, um, and it can automatically free the resource when the object is collected by the garbage collector. So for example, I have this database sync API that I import from like a SQLite package, and then I can create the database. I can then use it a bunch of times and then just leave it there. And the JavaScript garbage collector will just do its job. And if the DB is not used anymore, it will automatically free it for us. Um, internally, this looks like this. This is Rust code. And yeah, so you can see there's a pointer that holds the SQLite 3 native object. And then we implement drop on it, and then this closes the pointer. So once database sync is deallocated, this will also deallocate the SQLite pointer. And this also wraps. So when we create the value, we will wrap it in a V8 object, a JavaScript object, and allocate it to Rust. So the drop handler works. So if you don't know how drop in Rust works, when you allocate something, every value can implement this trait called drop, and this function will run when this value is deallocated. Yeah, and there's another cool feature similar to Linux strace if you've used that. So strace will in Linux tell you all the syscalls that are happening in real time as the application runs. And it's quite useful for debugging stuff. So Dino itself has an strace-like feature called trace ops, which will, instead of syscalls, it will trace all the internal JavaScript APIs that are passing through the native side. So in our HTTP example, there was HTTP, like it waits for the request, and then it notifies that it is serving. It runs the event loop, takes a bunch of times, and then it sends the response back. So that's just an example, but you can use it using -- trace ops command line flag. And as a bonus, there's a little project of mine where we build a minimal Linux kernel using just Dino as the main user space program. And you can kind of imagine with a JavaScript runtime being the main user space, you have processes being web workers or like multi-threaded uh, isolates of JavaScript that run separately, isolated from each other. File descriptors become these resource IDs we talked about, integer handles, or like garbage collectible resources. Syscalls become these ops. These ones, the native side, the native functions. And the scheduler is Tokyo. Tokyo is a Rust-based event loop that Dino uses to drive all these I/O operations. Uh, and the strace alternative is trace ops. So you can look at this repo if you're interested in that. And this is how it looks. It's just a JavaScript read eval loop, and it's kind of useless on its own, but hopefully it just gives you an idea that how you know JavaScript is like a mini OS on its own. So if you want to get involved with Dino, you can go to GitHub, or you can join the community on Discord. You can open issues. If you have any ideas, feel free to tell them, or just contribute code in general. I'm happy to help. Um, Thanks. If you have any questions, you can ask them here or email me later.
So it looks like nobody has questions.
Awesome. Thanks.
Thank you, sir. It was a pleasure having you. Rashmi Ratan Patankar is an open source contributor and developer specializing in scientific computing and control systems. She has been actively involved in enhancing the Scilab control system toolbox and integrating AI assisted workflows into its development process. With experience in Scilab, GNU Octave, and open source collaboration, Rashmi focuses on bridging academic tools and community driven software. Her work emphasizes accelerating function development, maintaining software reliability. She is passionate about fostering AI driven innovation in the open source scientific computing ecosystem. Uh, you are on stage, and I think we can proceed with the event now.
Good evening, everyone. I'm Nikita, a semester long intern at FOSSI from PhD College of Technology.
And I am Akash. I am also a student, finally a student at PhD College of Technology, and a semester-long intern at FOSSI.
We are here to present our work on accelerating Scilab toolbox creation using AI. Um, we worked under FOSSI and under the Scilab project as a semester-long intern. About FOSSI, FOSSI stands for Free or Libre Open Source Software for Education. It is funded by the Ministry of Education, Government of India. They provide training and skill-based education. They upskill students and faculty of academic institutions through FLOS. They recognize the contributors through certificates, honorarium, and online recognition, which have been used by students and teachers to get internships, jobs, and scholarships for higher studies. Um, they also conduct various activities, hackathons, mapathons, internships, fellowships, and workshops. Among this, we participated in the internship program. We worked as a semester long intern developing Scilab toolboxes. About Scilab, Scilab is a free and open source software. It has excellent computational environment and it is a better solution to MATLAB. It has 95% compatibility. And other than this, Scilab has XOS, which is a good alternative to Scilab, as to Simulink, which is a graphic modeling software tool. Uh, and the Scilab also has some toolboxes. We worked in extending these toolboxes. And our motivation is FOSSI has reached out to over 100 colleges and assisted them with Scilab through various activities. Scilab has a large user base with 1 lakh plus downloads per month. But Scilab lacks toolboxes in specific domains, for example, in control system and signal processing domains. Hence, the toolbox development work initiated. We specifically worked on the control system toolbox development role.
Let me walk you through our methodology. First, we start with a function. Where we start with function selection. We identify all the relevant function and scripts from the Octave control toolbox that we need to put. Next comes the code translation. This involves line by line mapping, replacing Octave functions with their Scilab equivalents. Then we handle syntax and semantic adaptation. This step ensures differences in indexing, function arguments, and plotting behaviors are correctly addressed. Finally, we move to testing and validation. Here, we execute the code in both Octave and Scilab and carefully compare the outputs to ensure that translation is accurate. During this process, we encountered several challenges. Manual translation is slow and prone to errors because Octave and Scilab have different syntax and semantics. We need a line by line understanding. Some subfunctions in Octave are missing in Scilab, so we have to re-implement them manually. There are also behavior mismatches. For example, with the lab function, which solves lab now equation, uh, but the same input in Scilab and Octave give different outputs. So we have to adapt. We have to change the input for getting the same output. Additionally, Scilab lacks the Slickout library, which means we need to manually handle complex algorithms. Unsupported data types like ID data also need a complete redesign. And finally, the absence of ready test cases makes the validation manual and tedious. To address these challenges, we designed a toolbox development workflow using AI. Step 1 is function selection, similar to before, but here we are also note all dependencies. Step 2 is AI assisted code generation. We use large language models to translate code and suggest alternatives when no direct Scilab equivalent exists. Step 3 is testing and benchmarking. We run automated tests comparing the Scilab output against Octave and refine iteratively. Finally, we move to documentation and integration. We document validated function with example and integrate them into toolbox. This workflow not only speeds up the translation but also reduces errors and ensures reliability. Here is an example of our implementation. We have implemented totally 50 functions, out of which out of the 50 function, one is ML divide. We have translated the octave function, which is in the right side, and to a Scilab function, which is in the left side. And we have compared the results in both Scilab and Octave, so it matches. And the Scilab equivalent of the Octave function is accurate. And these are the 50 functions we have completed during our internships.
Along with the coding part, the documentation was also a very important part of the work. The documentation part typically consists of four key parts. The first one is the syntax, which describes the order in which the function evaluates its parameters. Then the parameters part, it details about the expected inputs and including their types and valid ranges. The description part provides an in-depth explanation in the function's behavior, including default settings, input-output expectations, dependencies, and other relevant information. And finally, the example part, which will show the sample usage of the function. So our future scope is to complete the remaining functions of the control system toolbox. We have completed only 50 functions. There are remaining about 100 functions. And to leverage AI to develop the additional Scilab toolboxes, enhance and optimize existing toolboxes, and improve user documentation and add more demos for a better user experience. So finally, we would like to thank the FOSSI team at IIT Bombay for the internship opportunity on Scilab Control Toolbox development. Our gratitude goes to Professor Kannan Mothgalya for his support and guidance. This project was part of the FOSSI semester-long internship. And thanks to Ms. Rashmi Patankar, Project Manager at FOSSI IIT Bombay, Ms. Vinita Parmar, Senior Project Manager at FOSSI IIT Bombay, and the Scilab team for their mentorship. We appreciate the Department of Electronics and Communication Engineering at PSG College of Technology for providing a strong foundation. Special thanks to Dr. Krishnaveni V, Head of EC at PSG College of Technology, for inspiring participation in this open source initiative. And thank you.
Thank you. Questions?
Does anyone have any questions? It looks like nobody has any questions. Thank you.
Thank you.
Thank you, sir.
Can we leave the room?
You can
Beg your pardon?
Can we leave the room?
Sure, sure. Thank you.
Hi, hello, can you hear me? Hello.
Yes.
Hi, so I can just start, right?
Yes, sir, you can.
Okay, okay, I will share my screen. Please wait a minute.
You can remove.
Hi, if there's no any problems, then I will just start my talk today. Uh, yeah, can I just start?
Sure, sir.
Yeah, thank you. So yeah, hi everyone, and sorry for the delay. So yeah, my name is Zhongchi Yu from Singapore Management University, and yeah, today I'm going to share our current ongoing research work on towards human-centric evaluation of security and stability in open source software. So yeah, first, it's very glad to have the opportunity here to talk with you guys about this topic. So actually, I can have a brief introduction about myself. So I'm currently the fourth year PhD student at Singapore Management University, and my main research focus is actually on cloud security and testing of softwares. So I'm currently also working on open printing, which is affiliation to Linux Foundation and with Till, and I'm mainly focusing on like leveraging like software testing approaches such as fuzzings into like improving the security of open source software qualities, specifically for open printing. So I will introduce open printing later as well. So today my talk will mainly focus on the four aspects of open source software development and yeah, so first is I will briefly introduce the open source software development and securities. And second, I will introduce the open source software evaluation matrix. So combining these together, we can have a more like a high level or systematic understandings of open source softwares. And also I will introduce like the case foundation of like in the era of large language models, how can we ensure and secure the securities of of like open source softwares, and also I will discuss about the future works we are doing on. So yeah, first let's take an overview of the open source software security. So this is according to the recent study and report from the open source security and risk analysis. And we can see that nowadays and currently like almost all the software and the code we're writing contains the contribution or the functionalities of open source softwares. And yeah, according to it, like 97% of the code spaces that contains open source. And also, uh, they do the scannings of like a very popular and a lot of softwares, and they find that most of them like contain its origin in the open source. So even if there is some like commercialized software, their origins and their components are like partially from the open source development. So therefore, open source software is actually very popular and it's widely used. But however, because everyone can contribute to the open source software, and actually the qualities of what open source software is has been long-term discussed topics in both academias and in the industries. So they find that actually also most of the accessed code bases contain vulnerable open source software, and also a lot of like code bases contain a very high impact or critical risk vulnerabilities, which demonstrate that if we are using the open source software, actually the code is not actually guaranteed to be safe. So a lot of like developers may have like a different levels of developing like abilities, and also they have their preferences. So some of them may actually introduce some vulnerabilities, or they have like mistakenly like write some bugs inside which can be exploited into a very like severe consequences. So therefore, it's very important for us to take a look at the vulnerabilities and also the securities of open source software. So today, actually, I can take some examples to show how popular the open source softwares are. So actually, you may know that there's a lot of software are pre-installed actually on your PC, personal computers. So this is a very simple example that I extracted all the like pre-installed softwares on both Ubuntu 2404 and also desktop version and for the server versions. So for the desktop, they have like 1,336 pre-installed software. So some of them actually you may be familiar with. For example, for the XE so this is a very popular like software we may every day we might use. However, for like the zip also, they may be widely used, but some of them you may never be heard of. But they are also pre-installed in your software, in your personal computers and in your systems, operating systems, that you might actually ignore their existence. And same for the server side of Ubuntu, which is actually it has 491 pre-installed softwares. So it's much less than the desktop because it has like a more simpler like functionalities. But still, that you might miss some of the softwares like pre-installed and you will never use it actually in your system. But so for take an example of overprinting actually, so a lot of you may use like a printers or like use printing services every day, but actually so overprinting has a lot of pre-installed software as well in your personal computer or operating systems. So also take the example of Ubuntu, which that we can see that there's a lot of these components pre-installed. And actually, so OpenPrint is a very functional and a very powerful tools. It is not only open source, but also focus on driverless printing. So if you want to print something that's open printing, you might be the first choice for you guys. But actually, so just like a couple months ago, as I recall, it's not. So there's a very severe exploit and the vulnerabilities that happens in open printing. And you may never be heard of this before. I mean, for this component, for example. So these four CVEs actually can be combined to a very severe security exploit for the servers or for the PCs which has like which is hosting the open printing component, which initially by the Kaspersky. So Kaspersky actually, so I will just briefly elaborate here. So Kaspersky actually will start and maintain a TCP UDP actually is a UDP protocol like services on your desktop. So if you are running your desktop, actually will monitor the if I recall it correctly, that is 631 port number that can host the like graphical graphical like interfaces for you to operate the cups, which is the open printing core of the open printing like services. But actually, so this port is open, but actually you may be like very hard to, or it is actually not everyone may like notice that your port is actually opened. So actually, this part, actually, if there is a vulnerability, actually, the vulnerability has stayed for this Kaspersky for a long time. And once the security and analytics that had find it, so initially it is assigned the CVSS score, which demonstrates the severities of the CVEs, actually initially to be the 9.9. But later, after the triages and the fixes by the developers in open printing, then the score is lowered. Like I don't forget, but it's still a very critical vulnerability. So same issues not happens only in open printing, but also in other open source softwares. So there are some examples. For example, for the GNU screen, which is a very popular terminal multitasker, and yeah, actually I used this actually a couple of years ago, so I suppose it's very widely used. And actually, recently the developers of Screen has officially recommended that the user should not using it anymore. Why? Because there is a lot of vulnerabilities that actually lacking the active maintenance from the community, and also very popular like a need restart. It's also like has a very severe like a privilege escalation bug, which has existed for over 10 years before discovery. And these softwares actually is also very widely used, and it can cause like it's caused by the poor security review and maintenance, which means that a lot of software. So we can conclude that there is a lot of software pre-installed on your on your personal computers or your operating systems. And you may use a lot of open source software that is also like very popular, and you may trust it like based on your own daily development preferences. But actually, both of the all of these open source softwares may have like very severe consequences when having like vulnerabilities, and maybe a lot of people like not a lot of people may consider it, and this open source software is just working like hard labors, like like usually they will not get a notice, and once it get noticed, and because of their vulnerabilities, they usually have very severe consequences and impact. So we can see that the security issues in open source software has like usually have a huge impact because a lot of people is using it, and it's actually like it can persist for a long time because actually there is I think there is a statement that usually for the security analytics and for the testing like developers, they may not be very familiar with the open source software like in the deep in compared to the original developer or the author for the open source software. But the same like the vice versa for the software developers, they may usually not be very familiar with software testing like techniques, and also for the security perspective of domain knowledges. So they may not be very like some of them like may not be very like pay attention or be like very professional in applying security practices in your open source software. So they might just overlook the real world practices. And also I encounter, like personally, I encounter a lot of cases when developers may regard the reported security vulnerabilities or the bugs as like, I will just fix it and nobody needs to know about it. And they just like fix the code and without any issue, issues or the CVE is assigned. So there's a need for the open source software to like have the continuous security maintenance and the evaluation. And also the communities and the vendors should have like shared responsibilities in contributing to the security of the open source software. Yeah, that's just for the background. And there is actually approaches like such as OpenSSF scorecard that is an open source tool that can deploy like over 30 security checks on open source software repos. So it will check the security practices and their like the development status for these software repos, and including the CIs, fuzzings, and also a lot of other like properties of these repos. And it covers like a branch protections. So this just for example, like dependency update practices, and for the deploying different tests. So it was assigned like a numeric score, like from 0 to 10 for each of the comparison. So it is actually widely used. I mean, OpenSSF scorecard is the first thing we come up if we want to evaluate or assess the performances or the security practices for open source software. And actually, I have done some like checks for open printing that CUPS has a very high score of average 7.5, and for the CUPS Pro C and for CUPS filters, which I have mentioned like previously, that they have experienced a lot of like not a lot of, but experienced several very severe security impacts. So they do have like the correlation that it has lower average lower OpenSF scorecard values. So, but actually there is some limitations for existing OpenSSF scorecards that actually it is not a very full security audit. So how can I make it? Is that it only checks a very like superficial aspect of the open source software, and it can only check the presence of the best practices. So how can I make it? Is that it just checks like whether your software only have tests or not. So it's like more like binary levels of checkings, but actually it does not have those like the impact or like the ranges for scoring the open source software. So for example, if this checks the unit test or the fuzzing like the properties, then it can only, if you have fuzzing test, if you only have one fuzzing test, it will also assign you like a 10 scores because it only checks whether you have it or not. And it cannot guarantee the absence of the vulnerabilities because it's not a dynamic test. So it only can check whether your code consists of certain properties or like characteristics of the development of a software. It actually cannot do a very comprehensive analysis. And secondly, it has a full sense of security. So actually, the higher score may still miss some critical risks because it's actually, as I mentioned, it's very coarse. How to put it? It's a very coarse like evaluation metrics to evaluate the open source software, and also it have very limited coverages for advanced threat models. So. And lastly, to put it together is that the evaluation matrix for open source software actually, the OSSF scorecard is actually, it's designed to be a very easy and very fast running. So it will take just a couple of seconds to finish the checking. So it's static, but actually it may miss some very important aspect from the developers. So why do we consider about developers is that actually the developers is the core and the main essence of the open source software because the developers actually is writing the code, right? And let's just ignore the current like state of our methods in leveraging the large language models in writing code, but just actually previously developed like these very important system levels and pre-installed softwares are mostly developed by the developers. So how can we evaluate like and how can we ignore the perspective or the like the matrix of developers in accessing the securities of like open source softwares? So so actually we have proposed like preliminary improvement of open source software, OpenSSF scorecard that we aim to leverage more of the developer-oriented approach in accessing the securities of the open source software repos. And also we designed some matrix emphasizing the daily practices and the even the personalities and the different characteristics of from the maintainers and the developers' behavior, so it can serve as a more dynamic way in reflecting the performances and the security practices of open source software. And there's I need to introduce a very like related work that is actually it has been done and had been widely used to in the open source software like communities. That is Trunk Factor. So Trunk Factor is have the same idea as ours. Is that it is actually a matrix to evaluate the importance of individual developers that must leave or like so it's just for example like get hit by a truck before the project become unmaintainable. So the more like the higher trunk factor means this project is more resilient, and because it requires a lot more developers in like they can all serve as a backbone and the main contributors in the open source software projects. And the lower trunk factors actually may reflect the high risk of abandonment or the security issues in this open source software, because the developers actually is only focused on these two, I mean, one or two like key developers. And once the key developers are gone, the whole project is collapse. So this is a very important example, and the matrix factors that can reflect to the previous screen example I have mentioned is that the developers can no longer be able to maintain their open source software, even though it is very popular and it is has been a long time. So we propose our solution on the project from 4 levels actually. So we propose by project level, test level, developer level, and security level in order to improve the overall scope, and also for the developers oriented method into the evaluating the security of open source software. So I go through it one by one in details. So it's, for the project level, actually, is that if we want to access the securities of open source software, then the first thing is that we can obtain the source code and also the different metadata of the open source software. Then we can see a lot of matrix extracting from the project. For example, we can get the at least we can get the scorecard numbers of OpenSSF scorecard that has already considered the licensing practices, the packagings, and also the setting of CI tests. So these are actually the meta properties of each of the open source software. And also we can still add more from the statistics level. So what is statistic level is that we can consider the annually, so how active is a project is. So a very healthy and a very security maintained project usually have a lot of new contributors, because there usually have some contributors leaving the organization or the project, and thus we need more contributors in. So we may consider different metrics, including the line of code of the project. So how many they are added, how many they are deleted annually, and from a different period of time. And also we can consider from different levels of the contributors' activities, including the commit level, PR levels, and also for the issue levels of the contributions. And lastly, we can consider consider all these project level matrix into one a project there is also from 0 to 100 of the numeric aspect of the factor to evaluate the security of open source software. So the second is that we focus on the testing level. So because my background is actually also on the software testings, so there are actually a lot of testing matrix in evaluating open source software. So not only for the open source software, but for all the softwares, there are a lot of testing methods. So there are some continuous testing tools like GitHub Actions, Jenkins, and Travis CI. They also have common practices for the OSS testing method, including the static code analysis or SAST. And we have usually the softwares may contain the unit testing, integration testings, fuzzing testings, and if you consider more dynamic testing method, you can also counting of the symbolic testings or the concolic testing. So that's more for the academic levels. But if we want to evaluate the securities and security practices and development of open source software, we can consider the testing methods not only for existing in the open source OpenSSF scorecard for the CI test, fuzzings, SST, etc. But we can also check the real performances and the efficiency and effectiveness of the tests. So how can we measure this? We can consider the code volumes, and also can consider the function levels of the coverage of the testings. So this is actually may vary from different languages. For example, it's very easy to consider or very easy to analyze the coverage of the function levels and the coverage of the code line levels in the traditional Python's or Golang based projects, but it's actually not applicable for all languages. For example, it might take more effort for us to analyze the C and C++ based based project, but it actually can be done, and it's just engineering effort. So combining this, we can not only provide like the traditional base, like we have binary levels, whether the software has test or not, but we can have like, is the test good? How good is the test, or how good can the test be covering the like functionalities, and also for the like a development of the open source software. So the next level is the key for our development. So previously, the OpenSSF scorecard only like calculate the numbers of contributors, and they may like vary it from consider it as one of the factors in evaluating the projects. But actually, we want to propose more metrics into the developers levels, or the developer oriented like analysis for the open source software. So we may consider like not only for we incorporate not only for the trunk factor, which is very straightforward for us to like analyze the numbers of key contributors in the project, and then we can monitor it from a periodical level. Then we can check it like compared to the last year, how many new developers are incoming and how many developers are left. And actually, we also aim to like analyze through the properties of the developers. So what is the property of the developers? It's actually the ages, the genders, the races, and a lot of different properties make assumed to be a contributor, and actually the distribution of the developers may somehow reflecting the security practices and for the like the overall level of the properties of for the open source software. So take one example. If a very old, for example, a very old open source software is actually like used by like most of the computer users. So take an example, a random project in Linux Foundation. Then what if the core developers, like the trunk factor, is very low, and so these key developers actually has a very higher age. So it is actually not very easy to identify them from the previous approaches, and especially for the OpenSSF scorecard. But this is actually also a very key problem if there is one popular project that has fewer new developers coming inside, but actually they are just maintained by some bunch of like senior developers, which may have like more challenges or like a more, how to say that, more unstable commitment in the contributing in the open source software in the for a long for like settled time. So, and lastly, we focus on the security level because our aim is to secure the open source software, and we consider more compared to the existing OpenSF scorecard, compared to like security policies, binary artifacts. So these are more like high levels of introducing how good the security of the open source software is. But also we can consider from the previous CVEs and also exploit. So the previous CVEs, we can extract them from the CVE database, which is currently maintained by the US government. And I suppose it's actually, there's also a lot of like open source CVE database that is available for us to track. And also, we may check the security labeled issues. So it is actually previously ignored, but it's very important because from my own practices, that not all the bugs, even it is related for security related, then it will not be get assigned of CVEs. So CVEs actually will only get assigned due to like, for example, an outsider has find vulnerabilities or like exploit for the project, then they can be assigned of CVEs. But if like internal developers find a bug, usually the bug just be a fix. So some of them may have like issues assigned, but it may mainly depend on the like the practices or design for the like from the project, but it's like not settled for all the practices. So yeah, so we should consider like these issues as well to improve the performances. So yeah, actually this is just a wrap up for the introducing our solutions for open source software. So we are currently actually actively running so all of like the project pre-installed in different distributions of the Linux like a distribution. So including the Ubuntu, CentOS, and Arch Linux, a lot of other distributions. So we aim to collect a different score numbers compared to the open source OpenSS scorecard. And we also doing like conducting interviews and surveys with OSS practitioners to get their insight and opinions from our like proposed approaches. So if you're interested, so we love to hear from you, and you can contact me, and I will leave my like contact in the later. So lastly, I would like to like discuss a little bit more like not only from the perspective of like the matrix in evaluating open source software. So as I am also participating in the fuzzing development of open printing, so I would like to like invite all the developers. And if you're interested, please consider joining the open source open printing like OSS Fuzz and OSS Fuzz Gene integration. Like we are currently working on to detect more bugs, and we aim to like secure and to write better tests for open printing project, because open printing is very important not only for the Linux Foundation, but it is important for all of us because we are actually using it every day. And we are also doing like a more like securing the open printing project. So yeah, both are welcome. So I would like to mention a little more about the large language models. So as I mentioned before, we have proposed a lot of different metrics in evaluating the security practice of open source software. But in the era of like the large language models, so a lot of things can be done. Actually, can be saved. Actually, the time can be saved due to the help of large language models. So we are also working on to leverage more large language models in helping us to secure and the foster of development in not only for open printings but also for the securities of open source software. So yeah, I'm more than willing to discuss later if we have questions regarding the LM-based approach. So yeah, that's all. Thank you for your time, and yeah, this all for my talk. So if you have any questions, you can contact me later, or you can ask me. I suppose there'll be a QA session.
Uh, so, anyone has any questions?
It looks like nobody has questions.
So,
Thank you, sir.
thank you, sir, for engaging in thought-provoking talk. Your academic perspective and insights have added immense value to our conference, and we are truly grateful for your time and contribution. Let's give him a warm round of applause.
Thank you.
Hello, sir. Good evening,
Hello.
everyone. It gives me great honor to introduce Mr. Manuel Haro, an inspiring leader and innovator. He is the CEO and founder of the Dedica Foundation, a docent investigador at UAZ CTO at Bolsa del Arte, and also a proud GNOME Foundation member. With his vast experience in technology, open source communities, and entrepreneurship, Mr. Haro brings a unique perspective on how innovation and collaboration can drive impactful change. We are truly privileged to have him with us today. Please join me in welcoming Mr. Manuel Haro.
Over to you, sir.
Hi. It's a pleasure for me to be here remotely, but uh, I I really excited to be part of Open Source Conference at Kanpur. It's a amazing event. It's very similar to the work that we are doing here in Mexico in Latam to impulse and to strengthen the FOSS community around the country, around the continent, to adopt, to develop, and to take advantage of the open source technologies. So we will talk about what we are doing right now at Mexico and another 8 countries around Latam. Uh, Thanks for the introduction. It's a pleasure to be here. So, our talk is about how we have maybe 12 years working to create to consolidate a model around the collaborative innovation, but the main focus is the talent catalyzing because the talent of the universities like IT Kanpur, like any kind of universities around the world, the talent is over there because the youngs have all the talent, all the skills, and the universities is working to strengthen the knowledge, to strengthen the skills to be amazing leaders and the main actors to the new technologies to strengthen innovation around the world. So uh, one of the principal strengths for us is we are working like a community academic community. We are working right now with around 56 universities, not only in Mexico. We are working with universities at Colombia, universities at Ecuador, at Chile, Argentina. So really is a great community. The principal advantage is we are countries, very similar countries, so the culture and the idiosyncrasy is very similar. And this is very well for the model. And this universities is working very close to the or events or strategies to strengthen the FOSS communities and the FOSS culture around Latam. One of the main strategies for us in the DICA Foundation in Spanish is Desarrollo Digital y Conocimiento Abierto. In English, the DICA is Open Knowledge and Digital Development. Is the name in the English by the letters. So we have the main strategy for the DICA Foundation is Open Source Innovation Labs Network. That is a very important plan to strengthen and to get the engage from universities, engage from the students to work around these open source innovation labs, working with projects, collaborative projects, not only in the same universities where they are studying, they are working together with another universities where we have another open source innovation labs. So the strategy is about around innovation and collaboration is a network of innovation and collaboration laboratories deployed and led by universities. Uh, Obviously, like I was talking, strengthened by academic communities. Right now, we have a agreement with 56 universities, and 25 of these universities is deployed open source innovation lab over there. The main activities obviously is development of project collaborative projects, all the projects, all the technologies, all the solutions that we are working to develop this kind of projects is only working exclusively with open source technologies. Uh, we work to create and to schedule a strong schedule of technical training programs. Sorry, we are working to organize specialized events for all events from the Federica Foundation and our community, and working with another global events like with Genome Foundation, with KDE, with Linux Foundation, a lot of a lot of leaders around the world that are working with FOSS. And active participation in FOSS events like this, like this is this moment working with you at Opportunity Open Source Congress. This is the list of the catalog of the OSIL Network Community FOSS events. LATAM Open Source Tech Summit is like international congress working over technology, open source technologies. We have very important keynote speakers. We have a complete schedule of technical talks, workshops, and obviously in this event is organized at universities from our community and working together with this university that can be in any university I'm sorry in any city around Latam, but from this university we try to get the participation from another universities, not only in another cities and in another countries. Open Source Tech Talks is a meetup event. A meetup event. I'm sorry, LOTS Latam Open Source Tech Summit. Uh, the regular way is for 3 years. Open Source Tech Talk is a meetup for 4 hours, where we are working and we are making networking. We are working together, sharing knowledge. The open source talk is thematic. We can talk one edition of open source talks. We can talk about AI. Another we can talk about Web3. We can talk about cybersecurity. I don't know the technologies that the communities and the universities uh, wants to know or wants to hear of the specialist people. A challenge is our main model of hackathon. A challenge is a hackathon that we are working from the last year for 10 editions. Right, the next week we have the next hackathon over here at Zacatecas in Mexico, and we are working for the model of the challenge is focused to principal problematics in the regions when we are working with this event hackathon. We will talk a little bit late about the Innova challenge. This is a great event cause, and we want to invite to you to get involved in cause. Cause in Spanish is a event that was led from 2019 for Google Open Source, Apache Software Foundation, Linux Foundation, and It's very different event. It's not lots. It's not like lots. It's not like open source tech talks. This is a focused to people that is making commits to open source projects. Open source projects from Foundation, open source projects for Linux Foundation, for Savix, Apache Software Foundation, all these leaders around the world that are working with projects, but we are trying to strengthen the culture like a commuters, not like a users, not only using. So making better the solution open source that we have right now, where the creating committees commits around these projects. And this another event is a continental event, FLISOL. Uh, it's even like a community, like open source tech talks, but over the years, we have the last Friday of April each year we have FLISOL, and this year we was have I don't know, maybe 385 sites working with Clisol together and in the same time. The another event that we are working together, Linux App Summit. We have 4 or 5 years working like speakers in the Linux App Summit. The last years we have Linux App Summit here in Mexico in Monterrey. Genome Latam is a strategy from Genome Foundation. Genome Latam working together with Genome Africa, Genome Asia, WARIC, and Europe, and we are leading the organization, the Genome Latam, and we will have Genome Latam this year here in Mexico in a city named Aguascalientes, 14 and 15 of November. Open source tech talk, like I was talking the last image, Open Source Innovation Lab, and Innova Challenge. For Network Community Latam, we are working very strong to Genome Foundation, and we are working around with the universities because the students the students need to have a link with another sectors like industry, like a government, like companies. This kind of project we work very close with this instance from government, from companies, and we work to have the problematics or the needed to have a development of project. We create a catalog of projects, and the people of universities, students at the last semesters take these projects and working inside of these companies, inside of this dependence of government, with a very high possibilities to be contracted and to get work very easy. And this begins with a linked academic. This is activities that the students need to do. These projects share with all universities of the community, the students that this is the same in the same position in the same semesters can knows this kind of projects. Right now we have working with around, I don't know, let me think, it's about 20 projects, and we are working with around 60 students from 4 universities in right now. Obviously, we are working with the project technical projects from Genome and another kind of the companies or the foundation or instant leaders of the FOSS around the world, like Asavix. We will talk a little bit later. We work with creating software tools and apps development, documentation, or test. All the students that is working in this strategy with these projects have a very strong knowledge from the universities, a very strong formation, academic formation. The instance of companies and the government uh, regular expression is very surprised because the students are very strong to create the projects. We are participating in programs like GSOC, Google Summer of Code, and Norwich, regional projects. Uh, I don't know. Till till Campeter is leading this strategy from to outreach and to Google Summer of Code and knows about that. We have I don't know the last year I think or the last 2 years we have some students from India working with Genome Foundation around the Google Summer of Code and outreach, and I have the pleasure the in 2023 at the Riga, Latvia, to know these students and really amazing students, really they're really amazing youngs working in very important projects for Genome projects. Some of them right now is working like members of the Genome Foundation, and it's very important that the young people get involved in this kind of projects, get involved in this kind of foundations. So we are working very we are a lot of compromise to works around trending text. We have very clear that the AI, the artificial intelligence, right now is one of the main trending around the world. But we are working not only that our communities or not only or students or youngs working like a users, working using this kind of technologies like ChatGPT, like Google Bird. Right now is Google Gemini. Uh, Obviously, but it's needed to have the knowledge to like a prompt engineering. We are working like we see in the image at the left side. We are working to create this kind of technologies to teach to the students how this kind of technology was developed, was created. Not only with the idea that the students use these technologies, with the idea that they can works to create maybe another one technologies uh, later. Okay. We know these technologies is working all of these open source technologies like TensorFlow, like PyTorch, like OpenCV, obviously Python, the main, the most important language programming to develop algorithms, intelligent AI algorithms. I'm sorry. So in this kind of the technologies, the evolution of Apache Beam. If you don't know about Apache Beam, I want to invite to stalk over internet about Apache Beam. That we have a web page named apachebeam.org. We can know how is working this project, but is this project begins at 2018 and and is working, and the main instance working together with this is Google open source with Apache Software Foundation, because we know Google have a lot of information of us around the world, of the people, and Apache Software Foundation have all the technologies, tools, and solutions that can take advantage of of this data. So Apache Beam this is the strategy to work with Apache Beam. Apache Beam, Genome Foundation, KDE, Canonical, all these leaders around the world needs the talent of the young people around the world, because the technology is very fast. We need have talent to take the capacity to have the advantage of the technologies right now. Community engagement meetups is a regional community specialist genome meetup. We work around thematic meetups. We works one time of month with genome specialist thematic, organized at universities in person mode, share genome student projects to new users, genome, and we are working after we begins to work with Linux App Summit. We are working with KDE. It's very important in Mexico to work with genome and with KDE because here the culture is not too high to use Linux. We need to work to have the very strong culture to use Linux before we are thinking in another advanced topics. So genome and KDE is a very important solution to have the attraction to the people. Agenda topics uh, can be for advanced people or dummies people, Linux and genome onboarding talks, technical talks of genome suite and apps, technical of use and deploy genomes. If you can see over here in this image, we are working with adoption of Linux. Genome specialized, a challenge. We was work maybe I don't know 2018 in event named Genome Engagement Challenge. That was a global event like a hackathon, working with I don't know, maybe 80 countries around the world working to create a new solution to propose some ideas, working with FOSS and Genome and challenging Genome Hackathon. We are working to create over our model of genome over our model of a challenge focused to get the people, basically the people, developers, people that works with Linux to create new solutions over genome and over another kind of Linux solutions. The Innova Challenge mainly was created for uh, another alliance here in Mexico, Claudio Cosillo, at 2017, I think. And the hackathon is based in the Lean Startup model. Have a structure of three or four technical tracks for challenge. It's like a tracks. Specific the rubrics for each track. Each track must to be the specific rubrics to have the align the developers to create the solution that we need to have. Prioritize technical development and contribution to project documentation and feedback. Define the prices for the first places per track, in person or hybrid, whichever is better. A challenge. All the past edition that we was work around hackathon over a challenge, we was work in person. It's amazing how very important leaders around the world that they are working with FOSS is coming to Latam. Is coming to Latam because they knows in Latam, like in India, like another countries, but in Latam the FOSS culture is very strong, like a community is very strong, like a freelancers, but we need to have we need to have a community. We need to create a strong community that can be work together and take advantage of all these kind of leaders. Foundation, OECD have a plan of interns, and then we from the Rica Foundation for the past three years we are working to each semester. We are sending some students to have the interns at the Paris headquarters of the OECD, and the experience is really excited. They're really excited the experience for the guys. And with the Linux Foundation, with a lot of events over here in Mexico and Latam, ICP Internet Computer Protocol from the Ubuntu Foundation is a very strong protocol to develop Web3 is focused to technical development of solution Web3, decentralized solution. It's not working around trading, it's not working around staking, it's working to create new solution in a model Web3 decentralized technologies. Drone Code Foundation, that is a foundation supported by Linux Foundation, and Drone Code is working around the create open source drones. But from the main step, the first step to construct the drone. Apache Software Foundation, LibreOffice, Intel, Solana is another protocol of Web3, and Savix. Savix is a company from Letonia, and they are working hard because the solution of Savix is very strong to monitoring any kind of devices connected to the network. Around the Web3, the last year we worked creating for 10 months 10 boot camps. We have 1,500 developers trained and capacity with capacity very strong capacitation around Web3 over ICP, and we have 100 certified. We was developed for Innova Challenge hackathons with around 1,200 hackers working together in the for with an average of 300 hackers working in each hackathon, and they was developed around 200 projects. From these projects was incubated and have funding three projects. Projects with like a service right now. We have two projects. The main problematic here in Mexico is the people have a lot of the skills, have a very strong skills and knowledge, technical knowledge, but don't have the mindset to make business. No have the knowledge, the skills, the mindset to think this solution, this idea, working created around the hackathons, around the boot camps, can be a very successful business in the next steps. And don't work to go this roadmap. Don't follow the project to this model of business. Then the working and the projects stop at the end of the hackathons, at the deliver of the price, but the projects, there are projects that can be a very successful model business, but the students, the developers, the hackers don't have this mindset. We are working to strengthen this mindset, this knowledge, this vision, and we have a new model of new Innova Challenge or hackathon focused like it's focused to works. These guys working with projects from hackathons, from the ideation model of hackathons, go to entrepreneur model hackathon. So we are working hard to to take the to take this step. This is the company that I was talking before, Savix. Please let's check the web page of Savix, savix.com. We Savix is a open totally as 100% open source project developer. Uh, they have the Savix solution at GitHub. They have the repo. We can deploy in any kind of computer. It's very easy to deploy, but it's very strong solution to monitor any kind of device attached to the network. We are working in Mexico with Savix program education, and we are teaching right now teachers. We are capacitating teachers and certifying teachers. That the next step, the teachers share the knowledge from Savix to the students. So the image that you see there is Innova Challenge over Savix. As you see, Innova Challenge is very practical because we can align the Innova Challenge hackathon to any kind of requirements that we have to deploy. Right now, we have a request from a company, Emmanuel. We need to have a hackathon, internal hackathon in my company to create new solution for my company. So it's a very different focus because the company knows what they need. So it's very important because in the regular hackathons, the ideas don't have the client, we don't have the vision, the usability and viability. So with Savi's work, this hackathon was very amazing. Was very amazing. Right now, this is a hackathon that we are working together here in Mexico in a city named Fresnillo, and this is the process right now. The registration is open right now. We will close the next Saturday at midnight of next Saturday. We have 94 hackers registered right now. The people must to be 4 people, and this we have around 25 projects that we have that we will develop around the hackathon. So obviously, like a first user, like a Generation X man, uh, I am a proud genomer because genome and KDE, I was work for around 30 years, around FOSS, around Linux, around all open source solutions. I am a pro genomer. I am I am first ever Generation X man. So it was a amazing pleasure to be there, to be here with you. It's very sad. I was trying to be in person with you. I was very excited to be with you in person. I'm sorry, but I will work to the next year. It can be the pleasure to meet you in person and to work to you in person. So any kind of the requirements, any kind of due that you have, this is my emails. This is the web page of the Dedica Foundation, and this is the Twitter the accounts for my personal and the community Osilmx. So thanks for the time. I don't know if there are any kind of questions. I don't know. I am here. Thank you.
Any questions, anyone? Thank you, sir. It looks like there are no further questions.
Okay, thank you. Thanks to you. Have a good day. Have a good day.
Thank
Thank
you.
you.
Thank you, sir. You too.
Thank you.